Mankind has always had the need to create spaces and shelters, and so architecture has evolved seamlessly along with the growth in civilization. And as it grew, it aligned itself with the fields of science and technology. But equally, it was an aesthetic discipline. Hi, I'm Sneha Gupta, and in this episode of Building Blocks of India, we are going to explore various designs and patterns that populated architecture. And not just any patterns that are propelled by science. These will vary from the golden ratio to the idea of symmetry.
As we travel across India exploring architecture, it is clear that a huge understanding of mathematics powered much of our design. Wondering how? Well, ancient India had a great understanding of mathematics, and this propelled many facets of design. For example, buildings were laid out with specific proportions and ratios. One can see this in India, starting with the Harappan civilization, all the way till the modern city of Chandigarh. The famous ratio that echoes in architecture is known as the golden ratio. Let's quickly see how that works before we explore it in architecture. Take a line, divide it into two halves, A and B, so that the longer part divided by the smaller, which is A by B, is equal to the whole length, which is A plus B divided by the longer part A. So, A plus B divided by A is equal to A by B. And if we resolve this, we get this ratio to be 1.61803398874989484420. The digits go on, and do this number, which is usually called pi. It is usually rounded off to 1.618. This number is known as the golden mean. Historically, the number can be seen in the architecture of many ancient creations like the Parthenon. In the Great Pyramid of Giza, the length of each side of the base is 230 meters with a height of 146 meters. The ratio of the base to the height is roughly 1.5717, which is close to the golden ratio. Almost all ancient Hindu temples follow a set of design guidelines. Usually the height of the temple should be double its width, and the height of the foundation above the ground with the steps equal to a third of this height. The sanctum sanctorum should be half the width of the temple, and so on. These guidelines translate into various interpretations of the golden mean. But the most famous example of the use of the golden mean is the Taj Mahal. As we can see, if we break up various sections of the Taj, the ratios will be close to pi, which is the golden mean. For example, the width of its grand central arch to its width, and also in height of the windows inside the arch to the height of the main section below the domes, all translate into the golden mean. Another common mathematical concept also inherent in the Taj is symmetry. The symmetry here is quite visible. This line down the middle splits the Taj into two identical halves. Let's look at the mathematics of symmetry in theory once before exploring it in more detail in architecture. Mathematically, symmetry means that one shape becomes exactly like another when you move it in the same way, turn, flip or slide. The dashed lines below are not lines of symmetry. Though they do cut the figures in half, they don't create mirror image halves. So what we see in the Taj is a kind of symmetry known as line symmetry or mirror or reflection symmetry. Basically, the object here is reflected across a line like a mirror. A small detail in the Taj, the line of small fountainheads in front of the Taj divide the structure exactly in half to the mirror. Quite miraculous, right? Reflection symmetries also abound in the decorations made from precious and semi-precious stones inlaid on white translucent marble. Line symmetry like this can be seen in many monuments across India. The famous Sanchi Stoop, the Ellora Caves in Aurangabad, the temple at Rameshwaram, and India Gate. Another kind of symmetry, which is less common, is radial symmetry or rotational symmetry. This is largely symmetry about a central axis, as in a starfish or a snowflake. These are often seen on ceilings of all kinds of monuments or in stained glass windows in churches. But one structure that we want to explore in more detail is the famous Lotus Temple in Delhi. This temple was made by the Baha'is. It looks like a lotus from the bottom with 3 rows of lotus petals containing 9 petals in every row. The outer set of 9 petals open outwards, forming 9 portals. Encircling the lotus-shaped structure are 9 pools which represent the green leaves of the lotus plant. Special building materials were used to build the structure. The white cement from Korea, white marble from the Pentelicon mines in Greece but cut in Italy, the concrete dolomite aggregates of Alwar mines near Delhi, and the white silica sand from Jaipur, India. The structure was built over a period of 6 to 7 years. From a frontal view, the structure is symmetric, but the symmetry really comes alive if we move up and get an aerial view of the monument. From the Baha'i temple, let us move to another stunning religious structure, the temples at Khajuraho. This temple is called the Kandarya Mahadev Temple. Now, if you look at the tower or shikhar, we see that they are surrounded by smaller towers, and then still smaller towers, and so on for many levels. Now, this repetition is a very complex form of mathematics called fractals. Very simply, a fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. Now, if we look at the shikhar again, can't you see a fractal structure? There are in fact 84 fractals, ascending together and culminating at the spire. Each of these smaller towers is designed to look like a miniature reproduction of the whole. We can see this fractal pattern in a host of other temples, like the Virupaksh temple at Hampi and the Madurai Meenakshi temple. There's a philosophical angle to this mathematics also. Each fragment of the cosmos is believed to be whole in itself. And so the temples are designed and constructed as models of the cosmos. With this thought, let us move from a temple to a tomb. This tomb was built for the Mughal Emperor Humayun. Now, underlying the beauty of this tomb is a load of science and technology. Starting from the layout, the tomb proper stands in the center of a square garden divided into 4 main parterres by causeways, charbagh, which basically indicates a quadrilateral garden divided by walkways or flowing water into smaller parts. Now the plan of the tomb itself is also. It is a square 9-fold plan where 8 two-storied vaulted chambers radiate from the central double-height domed chamber. The chambers of each level are interconnected by straight and diagonal passages. In Humayun's tomb, each of the main chambers has in turn 8 more smaller chambers radiating from it. If we wander through the tomb looking at the patterns, we will see a certain mathematical symmetry in them. These kind of patterns are called tilings or tessellations. We see them equally in other Mughal and Islamic monuments like Fatehpur Sikri.
We discussed the never-ending patterns in some of our religious architecture, which are in geometric patterns. It is going to be quite a journey after this break. Welcome back after the break. We are discussing building blocks of India, and now we are going to explore various designs and patterns.
A tessellation or tiling is when we cover a surface with a pattern of flat shapes so that there are no overlaps or gaps. These should have the ability to stretch on to infinity. Now, you can create tilings by repeating on shape like a triangle, a square, or a hexagon. These are called regular tilings. You can also create a tiling by combining different shapes, like a triangle and a square, or a triangle and a square and a hexagon. This kind of mathematical patterning was very common in Islamic structures, since they didn't portray realistic animal or human figures. It was first believed that the artisans were able to construct an entire tiling using only a straight edge and compass. Later it was found that this long process would be potentially impossible considering how errorless and complex patterns were. Later research revealed that these intricate geometric patterns were created by repeating 5 tiles called Giri tiles. These were the tiles: a regular decagon with 10 interior angles of 144 degrees, an elongated irregular convex hexagon with interior angles of 72 degrees, 144 degrees, 144 degrees, 72 degrees, 144 degrees and 144 degrees. A bow tie non-convex hexagon with interior angles of 72 degrees, 72 degrees, 216 degrees, 72 degrees, 72 degrees and 216 degrees. A rhombus with interior angles of 72 degrees, 108 degrees, 72 degrees, 108 degrees, and a regular pentagon with 5 interior angles of 108 degrees. We can see how these patterns come together in a multitude of ways to create these mesmerizing patterns. Let's leave these patterns and head to our final destination, which is to explore some stunning paintings. These paintings adorn the walls of the stunning Ajanta caves in Aurangabad district of Maharashtra state. These are rock temples, places of worship created by carving out solid natural rock, often on a hillside or a cliff. Ajanta consists of 30 caves, each dedicated to the life of Buddha. These caves, 30 in all, are a combination of Buddhist prayer halls and monasteries carved, as if by sorcery, into the rock face in these mountains. Unknown for more than 1,000 years, these caves were discovered by accident in 1819. All of the caves at Ajanta fall into the category of viharas, monasteries with residence halls, or chaityagrihas, which are the shrines. So how are these caves made? Usually rock that is not part of the structure was removed until the only rock left created the architectural elements of the excavated interior. A notable trait of this kind of rock-cut architecture is the crafting of rock to imitate timbered and carved wood. So what are the techniques used here? First off, the outline must have been marked. Then excavation started from the ceiling, which was finished first. The work then continued downwards till the floor was reached. Cutting was probably done by using heavy instruments like crowbar, pickaxe, etc. The finishing and carving was entirely done by hammer and chisel. Most likely, the work of pouring, dressing and finishing went hand in hand. From the fact that even unfinished caves bear traces of paintings, it seems that chisel work and brush work proceeded simultaneously. So the caves were basically dug out from the rock face. Unwanted rock was thrown away. The sculptures in these caves contain an impressive array of votive figures, accessory figures, narrative episodes, and decorative motifs. Again, the rock was soft enough to carve this way. But what stands out here are the paintings, which are unparalleled in the history of Indian art, both for the wide range of subjects and the medium. A large number of incidents from the life of Buddha are depicted, as well as tales from the Jataka legends. Overlapping figures suggest perspective, colors are harmoniously blended, and the line work is sinuous. However, the identities of the artists responsible for the execution of the Ajanta caves are unknown. This is characteristic of Indian traditions of anonymity and abnegation of self. Even today, these cave temples at Ajanta provide the most complete illustration of Buddhist tradition. So what are the techniques used here and how did they last so long? The painting techniques at Ajanta are similar to European fresco technique. The primary difference is that the layer of plaster was dry when it was painted. First, a rough plaster of clay, cow dung and rice husks were pressed on to the rough cave walls. This was then coated with lime juice in order to create a smooth working surface. The dark outlines of the figures were then added, followed by a palette of only 6 colors. The pigments the artists used came from natural resources: red and yellow ochre, crushed green malachite, blue lapis lazuli, etc. The meticulous restoration that was done on the art here raises anew questions asked many times over the past 200 years. How did the artists paint so well with such precise use of color in the dark recesses of these rock-carved prayer halls and monasteries? It's fascinating to imagine the hordes of architects, masons, sculptors and painters who must have been at work, and the fount of scientific knowledge that must have propelled the art and technique of these caves.
So it's been quite a journey through the geometry and techniques of architecture and the beauty it has created in the patterns and paintings that still adorn our ancient monuments. It brings home the thought that science underlies so much of what we see. We will meet you again with our next episode. Don't forget to share your views on feedback@indiascience.in. Till then, good day.